Professor. My name is Firasatul Hosseini Sayed. Today, I'll show you how big data analytics helped reduce 30-day hospital readmissions. I'll start with the business problem, then spend most of the time on technical architecture and data pipeline. So, coming to the business problem, readmissions within 30 days are costly and bad for patient outcomes. Hospitals in the US face penalties for high rates, but the drivers are complex medical history, medications, lab results, clinician notes, even social factors. Traditional reporting is backwards looking and slow. Clinicians need a real time risk score at discharge to act before the patient leaves. So the kind of data we use to predict this risk, we combine multiple data types, structured EHR data diagnoses, vitals, procedures, meds, and claims. Semi-structured data, labs, devices, feeds in JSON or XML. Unstructured data notes and discharge summaries where critical details often live. This is high volume and high velocity. A single rational database cannot ingest, process, and score in time. So we use big data architecture. So coming to the fourth slide, the big data architecture. Here's the architecture. The sources are EHR, labs, claims, nodes, devices. Feed the problem like the platform via Kafka for streams and scheduled batch ETLs for historical loads. Data lands in an HDFS or S3 data lake, a bronze, silver, gold layout. So bronze holds raw, immutable data. Silver is cleaned and standardized to medical vocabularies like according to ICD and Law Inc. Gold is analytics ready Hive tables. Spark does the heavy lifting, joins imputations and NLP on nodes to extract problems and medications adherence signals. We generate a patient feature vector labs, prior admits, coordinates, med counts, recent procedures, and NLP flags. For low latency scored during discharge, features are written to HBase using patient ID. K means cluster patient cohorts like frailty, cardiometabolic. A classifier outputs readmission risk factor. Scores are served through a REST API into the EHR's discharge workflow, so clinicians see the risk in real time. Around the edges, we enforce governance and security uh, RBAC encryption in transit at rest and audit logs for HIPAA. Coming to the pipeline details, ingestion on Kafka, one Kafka topic per source, late arriving records handled with watermarks, feature engineering. So Spark computes rolling features like last HB1AC, prior admits, and stores them in Hive Plus the Edge database. Model training, batch nightly or weekly, like Spark ML trains k-means for segments and SVM for risk classifiers. Models are versioned in a registry, serving the scoring API pulls the latest features from HBase. Median latency in under 200 milliseconds, which is fast enough for discharge decisions. Coming to the next slide, the technical training and interference. So two flows. Training gold hive tables, Spark ML model registry deploy to the API. Interference in inference. New event hit Kafka features updates in HBase API scores, then it goes to EHR, shows the risks and recommends actions. So coming to the next slide, security and compliance, because this is a PHI, so we apply least privilege RBACs, TLS, and KMS backed encryption at rest. Access is logged, pipeline runs via Airflow jobs, and we monitor AUC precisions and drift. Uh, if performance drops, we auto roll back the model and alert data science. So coming to the next slide, outcome and limitations. Because of see pilots using this pipeline achieve 8 to 15% reduction in readmissions for target cohorts, fewer penalties, and better discharge planning. The key isn't just to model, it's the end-to-end architecture that delivers timely, trustworthy scores. So, thank you for listening.